Hello everyone, this is teacher Kevin Guillermo, MSc Mathematics student of St. Paul University, Philippines Graduate School. This video presentation is a course requirement in math analysis for teachers under Dr. Jess Pizarro. Also, in this video presentation, I will share with you the topic assigned to me by Dr. Pizarro, which is the derivatives of trigonometric functions. To begin with, let's familiarize ourselves with the 6 basic derivatives of trigonometric functions. First is the derivative of sine x. With respect to x is cosine x. Second, the derivative of cosine x with respect to x is negative sine x. Third, the derivative of tan x with respect to x is 1 over cosine square x equals secant square x. Next, the derivative of cotangent x with respect to x is negative 1 over sine square x equals negative cosecant square x. Next, the derivative of secant x with respect to x is the product of secant x tan x. Lastly, the derivative of cosecant x with respect to x is negative cosecant x cotangent x. Let's consider example number 1. Find the derivative of the function f of x equals x cubed plus sine x plus 4 cosine x. So here is the solution. Copy the given function f of x. Then we have this symbol is the first derivative of the function f of x, or the f prime of x is equal to 3x squared. Bring down 3 to the left side of x, then less 1 to the exponent to make it 2, plus the derivative of sine x, which is cosine x, plus 4 times the derivative of cosine x, and that is negative sine x. Therefore, the derivative of the given function f of x equals x cubed plus sine x plus 4 cosine x is 3x squared plus cosine x minus 4 sine x. Moving on to the second example, find the derivative of the function f of x equals x squared sine x. As you can see, the given function f of x is actually the product of two functions, considering x squared be the first function and sine x be the second function. Hence, in this example, let us use the product rule. So the product rule says that if f and g are both differentiable, then the derivative of f of x times g of x with respect to x is equal to the derivative of f of x times g of x plus the derivative of g of x times f of x. Here is the solution. Copy the given function f of x equals x squared sine x. Then the first derivative, or the derivative of f of x, is equal to the derivative of x squared, that is 2x. Bring down 2 to the left side of x, then less 1 to the exponent, times sine x, plus carry x squared times the derivative of sine x, and that is cosine x. Therefore, the derivative of the function f of x equals x squared sine x is 2x sine x plus x squared cosine x. Let's proceed to the third example. Find the derivative of y equals x sine x plus cosine x. Using the linear properties of derivative and the product rule, we obtain y prime equals 1. 1 here is the derivative of x times sine x plus x times the derivative of sine x, that is cosine x, plus the derivative of cosine x, that is negative sine x. Y prime equals 1 times sine x is sine x plus x times cosine x is x cosine x minus sine x, because the product of a positive and a negative number is a negative number. By combining like terms, the derivative of y equals x sine x plus cosine x is now x cosine x. Because when you add sine x and negative sine x, it will give you a zero answer. And 0 plus x cosine x is actually x cosine x. Let's proceed to example number 4. Find the derivative of y equals quantity x plus 1 cosine x plus quantity x plus 2 sine x. By product rule, we obtain y prime equals the derivative of x plus 1 is 1, because the derivative of x is 1 plus the derivative of a constant 1 is 0. Then 1 plus 0, the answer is 1 times cosine x plus 1 times the derivative of cosine x, that is negative sine x, plus the derivative of x plus 2, that is 1 times sine x, plus copy x plus 2 times the derivative of sine x, which is cosine x. Y prime equals 1 times cosine x is cosine x. Now distribute x plus 1 to negative sine x. We have negative x sine x minus sine x, plus 1 times sine x is sine x, plus again distribute x plus 2 to cosine x. We obtain x cosine x plus 2 cosine x. By combining like terms, we can now say that y prime equals 3 cosine x, because when we add cosine x and 2 cosine x, the sum is 3 cosine x, plus x cosine x minus x sine x. Therefore, the derivative of y equals x plus 1 cosine x plus quantity x plus 2 sine x is 3 cosine x plus x times cosine x minus sine x. Let's consider this example. Find the derivative of y equals tan x plus 1 over 3 cubic tan x. By applying the linear properties of the derivative and the power rule, we obtain y prime equals the derivative of tan x is 1 over cosine square x plus 1 over 3 times the derivative of tan cube x is 3 tan square x. Bring down 3 to the left side of tan. then less 1 to the exponent to make it 2 times the derivative of tan x, and that is 1 over cosine square x. Y prime equals 1 over cosine square x plus tan square x times 1 over cosine square x. Y prime equals 1 plus tan square x over cosine square x. We can simplify the numerator of y prime equals 1 plus tan square x over cosine square x using the trigonometric identity 1 plus tan square x equals sine square x plus 1 over cosine square x. We have y prime equals 1 over cosine square x over cosine square x. Y prime equals 1 over cosine raised to 4 or to the fourth power x. Therefore, the derivative of y is secant raised to the fourth power x. Let's proceed to example number 6. Find the derivative of y equals sine x over 1 plus cosine x. As you can see, the given function y is the quotient of two functions. Considering sine x be the first function and 1 plus cosine x be the other function. So let's recall the quotient rule. And in quotient rule, if f and g are both differentiable, then the derivative of f of x over g of x with respect to x is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x over g of x squared. Following the quotient rule, we obtain y prime equals the derivative of sine x, that is cosine x, times the denominator 1 plus cosine x, minus the numerator sine x times the derivative of the denominator 1 plus cosine x, that is negative sine x, over 1 plus cosine x squared. Now, distribute cosine x to 1 plus cosine x. We have y prime equals cosine x plus cosine square x. Then, multiply negative sine x times negative sine x is positive sine square x over 1 plus cosine x squared. We can simplify the numerator of this expression, y prime equals cosine x plus cosine square x plus sine square x over 1 plus cosine x squared, using the trigonometric identity sine square x plus cosine square x equals 1. We have y prime equals 1 plus cosine x over 1 plus cosine x squared. Now we can cancel the numerator 1 plus cosine x and subtract 1 to the exponent of the denominator. Therefore, the derivative of sine x over 1 plus cosine x is 1 over 1 plus cosine x. So let's proceed to example number 7. Find the derivative of y equals cosine x minus 1 over 3 cosine cube x. Applying the quotient rule and the chain rule, we get y prime equals the derivative of cosine x, that is negative sine x, minus 1 over 3 times the derivative of cosine cube x, that is 3 cosine square x, times the derivative of cosine x, that is negative sine x. Y prime equals negative sine x plus cosine square x sine x. Because when you multiply negative number to a negative number, the product is a positive number. As you can see in this expression, the common factor of negative sine x plus cosine square x sine x is negative sine x. Thus, y prime equals negative sine x times 1 minus cosine square x. And actually, 1 minus cosine square x is actually a trigonometric identity. Cosine square x plus sine square x equals 1. And this 1 minus cosine square x is equal to sine square x. So y prime equals negative sine x sine square x. Therefore, the derivative of y equals cosine x minus 1 over 3 cosine cube x is negative sine cube x. Now, let's proceed to our last example. Calculate or find the derivative of y equals cosine 2x minus 2 sine x. As you can see, cosine 2x is actually a composite function. Considering cosine x be your f of x and 2x be your g of x. This expression, cosine 2x, is actually a composite function f of g of x. So to solve this example, let's recall the chain rule. If f and g are both differentiable and f of x is a composite function defined by f of x equals f of g of x, then if f is differentiable and f prime is given by the product, f prime of x equals the derivative of f prime of g of x times g prime of x. So following the chain rule, we get the derivative of cosine, that is negative sine. Copy the angle 2x times the derivative of 2x, that is 2, minus 2 times the derivative of sine x, that is cosine x. Y prime equals negative sine x, sine 2x times x is negative 2 sine 2x minus 2 cosine x. Y prime equals negative 2 sine x cosine x minus 2 cosine x using the double angle formula. Therefore, the derivative of y equals cosine 2x minus 2 sine x is y prime equals negative 2 cosine x times sine x plus 1. So that concludes my discussion about the derivative of the trigonometric functions. Thank you for listening and God bless us all.